Welcome back to the sixth installment of the AR15 Gasblock machining video series. In this episode, we're going to be working on fixture plate number 2. This is the one that holds them so I can access the sides. So I start off by spotting and drilling the holes, and I learned my lesson from the first fixture plate. I did this step first where I machined the bosses, and then I went back and drilled and tapped the main hole there. That was a mistake because apparently tapping them can change the outer diameter of that boss, and it did to where they no longer fit. So I had to go back and finish machine them again. So this time I drill and tap the holes first, and then I go back and machine the bosses. And then also on this one, I'm putting a little chamfer on the edge there. And I didn't make the bosses quite as tall. I made them 100 thousandths tall instead of 200 thousandths. As I found, there's really no reason to make them as tall as I did on the last one. And it can just make them harder to put on and off. Put the gas blocks on and off. So this is just the cam simulation before we get started. I started out with just a raw chunk of steel. Those are the bosses put in there. And my cam program is assuming I've already squared it up. That's sort of how they would look. I don't have everything oriented correctly, but that one is actually oriented right. That's where the gas block would theoretically be inside of the material. And there they are sticking out from the side. That's how they would be when they're on the vise machined in the process of being machined. But right now I have the bosses sticking straight up just to make it easier on me to program it. And it's going to be both sides done like that, so I can put a total of 4 on each side. And there's the picture I was looking for. That's what I was trying to show. Basically, it'll hold 8 of them, kind of across from each other. And there's the raw piece of steel. I start out by squaring it up with a facemill. So let's get started here. There's not a whole lot to see here, so I didn't really spend that much time videoing, just squaring up this big chunk of steel. So this leaves a beautiful surface finish. And I didn't show it either, but I threw it up on the surface plate and checked the squareness, and it was just spot on. So I wanted also to square up the ends, and I thought I might use that opportunity to experiment with a few full depth finish cuts. So I'm using the end mill that I always get chatter with, and I'm trying a full depth finish pass here, and this is 2/1000th width of cut, and the thickness of that bar is about 1.5 inches. And I'm leaving a little overhang on the end because I don't want any stress on the flute tips, because that's always the first thing to go on my end mills. And if you hear, I'm getting quite a bit of chatter here. This is a number from G-Wizard. Like a 1660 RPM. It's a little too fast, it seems, so I dialed it back, and the finish suffered. So I dialed it back to 1430 RPM, left everything else exactly the same. And that was a number where the chatter just started to go away. And that's where I left it. It probably stand to go just a tad lower too. But that left a great surface finish. I was very impressed with that. So I did the other side, and this just kind of shows how out of square these ends were, just cut on a bandsaw or a chop saw or whatever they use. And this is just my little handwritten code where it just comes in. This one I have it in the code where I can just adjust the parameters to whatever I want on the fly. And I changed it to a 2000 width of cut, which it was at a 5000, and I didn't leave it at 5000, so I didn't make any cuts at that width, but I'm sure it would have been fine. I just did 2000s because all I wanted to do was take the minimum amount of material off just to get a squared face. And apparently I had to take more than I thought, so I just kept doing multiple passes with 2000s. And this is still at the 1430 RPM. It sounds great, although you can tell it's kind of flirting with the idea of maybe chattering again. Which is why I might try 1400 next time. And I need to find a big, or like a taller piece of steel and try some like full depth, like 2-inch depth, to see if that's still okay. And if that's okay, then the next time I machine a gas block, I might do a full depth finish pass just to see how it turns out, and I'll just keep bumping the RPM down until the chatter goes away. And that left just a great surface finish. Very pleased with that. Much better than anything I've gotten before with that mill and a finish pass. That end mill, sorry. And that was kind of a crappy picture. I was just trying to show the reflection of the surface finish. Alright, so moving right along, now this is the spot drill. I drilled these spots deep enough to where it would leave a little chamfer after the drill, so I wouldn't have to go back and re-chamfer it. Now this drilling cycle worked out great, especially considering this drill bit wasn't very sharp. It wasn't a high quality one or anything. It wasn't dull, but it wasn't sharp. And I decided to use a bit more of aggressive feed rate here because I wanted to have a thicker chip, which might, break itself instead of becoming a long, springy, stringy thing. I also didn't do a full retract on the peck. I just did a brake chip, which worked out great. And in fact, in the future, I'm thinking about, instead of doing a brake chip retract, I'm thinking of just doing like a half-second dwell or something to break the chip. I haven't really decided yet. It's not a big deal. This works fine. But that might save a little bit of time on those long drilling operations on the gas block, which has to go down like 2.5 inches or so. But this worked great. The more aggressive feed rate definitely produced a thicker chip. You could pick it up and feel it. And they were in short pieces instead of long springs. So I think that's the key for chip control there. Make sure the chip is thick enough that it becomes brittle and breaks. Here's how I set up the tapping. I used a little automatic center punch I got from Lowe's to kind of center the tap, and just used a big handled tap wrench, and that worked great. You have to use a high quality tap. The first tap I used just sucked. Teeth broke off of it. It widened the bosses considerably. It was terrible. Okay, this is a pretty aggressive cut with a 3/8 inch roughing end mill. This is the speed and feed data from GWizard for the high speed machining, because I was taking a maximum width of cut of 200 thousandths, and that didn't change at all. So I just used the high speed machining checkbox, and it came up with these numbers, and it sounds great, and this went pretty quickly. 57.5 inches a minute or something. That's great. And that works out great and leaves a very nice surface finish on the floor. So I lowered the RPM and feed rate here, mainly because I'm going to be doing full slots on some of these. I could have kept the speed and speed rate, the speed and feed rate the same as before, but I'm just not sure how that would have handled it through that slot. GWizard didn't say I could do it, so I didn't want a chance breaking any more end mills. I'm sure it'd probably handle it fine though. So I just go through and remove the bulk of the material around where the bosses are going to be. And once that's done with, then I come back and I do sort of a profiling pass, removing as much material as I can with the 3/8 inch end mill around the two bosses. And each time I do any of these cuts, I come in and do a 5/1000th finish pass to clean up that floor, because that floor needs to be perfectly flat. It can't have any raised bumps or anything on it. And that worked out very well. It's very flat. In fact, if you close your eyes and run your hands across that surface, it feels like glass. And I come in with a 3/16 inch end mill here just to remove that excess material around the bosses and then clean up the floor. I decided to keep a pretty large radius on the engagement or the entry there because normally I would use a much smaller radius, but I kind of found that the larger radius leaves much less evidence that the end mill started and stopped at that point. In fact, this is a 1/4 inch radius. You can't even tell. There's no visible marks on the outside periphery of that boss to suggest where the end mill engaged and disengaged. And I sort of noticed that when I reduced that radius to an 1/8 inch radius entry. Also, I kind of accidentally programmed the disengagement, I guess if you want to call it that, of that radius at the rapid feed rate, so it pulls away too quickly. I went back and changed that. So that brings the diameter of the bosses down to their nominal size, which is too tight. It would be a press fit to try to put a gas block on there. So I come in and with some experimentation that I did with the original fixture plate, I came up with a number where the bosses were just the right size where you could fit a gas block on there to where it would be nice and snug. You'd have to tap it on with a hammer and there would be no play from side to side, but it would still go on there pretty easily. And that number was 8/10 under nominal size. So the bosses now, before they're being machined in this step, like the small boss is 0.180, which is the drilled hole of the gas block. So I'm removing 8/10 from that so it'll fit snugly. And the large boss, which is 14 millimeters. And that fits perfect. It didn't fit perfectly at first. It left a little bit of, there was a tiny little burr at the top edge of those bosses, which was making it fit tighter than I thought it should. So I decided to do something that I didn't do on the first fixture plate I made, and that is just sort of chamfer the edge. So I come in here and just put just the tiniest chamfer on there, just enough to get rid of that burr and maybe allow it to kind of ease into the gas block holes a little bit better in case there's a slight misalignment. And then I flip it over and do the exact same thing to the other side, which I'm not going to show, but here's some random shots of that. I was really surprised by how well those holes matched up after I flipped it over and then drilled them. It seems like there was no discrepancy between the holes coming in from one side and then meeting the new holes coming in from the other side. It was amazing. So they fit on just fine. Snug, you got to tap them on with a hammer, but that's exactly how I wanted them. I didn't want any play. And there's one side of it turned out great. The bosses turned out awesome. The surface finish, everything turned out great. There's one bolted on. And there's what it's going to look like on the vise when I actually machine these. So it'll hold one closest to you and one, or I'm sorry, it'll hold 4 of them on the near side and 4 of them on the other side. So it'll do one side of 8 of them at a time. And then I just simply flip it over in the vise, re-index, and then do the other side. Thanks for watching, and I won't have a video out next week. I'm going to be out of town, but I'll have something cool the week after that, I'm sure. So stay tuned, keep watching, share my videos, subscribe to my YouTube channel, like my Facebook page, visit my website at warmachinellc.com. Also, you can visit my blog at warmachinellc.com/blog to read more content about this episode. Also, I'm having a 20% off Memorial Day sale lasting from Friday the 23rd to Tuesday the 27th. So if you're a collector or a gamer or just someone who likes badass shit, that would be a good time to pick up some dice.